The purpose of this video is to introduce you to the idea of using corresponding parts of similar triangles. Before we get started with some proofs, let's review some concepts that we learned about similar triangles a couple days ago. First of all, you should remember that when two triangles are similar, their corresponding sides have to be in proportion. That's a big one. The next one that you need to know is that when you have two triangles that are similar, their corresponding angles are congruent. So keeping those two ideas in mind, we're going to move forward and write a couple of proofs here this afternoon. First things first, they give us this right triangle ABC in which angle C is a right angle. They tell us that DE and CA are perpendicular to each other. So the first thing I'm going to do is, of course, go mark the givens in my proof. So angle C is a right angle, I'll mark that. Segment DE is right here, segment CA is right there. They are perpendicular, meaning that they intersect to form right angles. And then take a look at what I'm given in my proofs. I'm being asked to prove that something is in proportion. Anytime you see that in a proof, I want you to think to yourself to use similar triangles. We know that anytime two triangles are similar, their corresponding sides are in proportion. So as soon as we see that proportion, we're going to think to ourselves, similar triangles. Now the sides that are being used in that proportion are side AD. I'm going to get my highlighters over here and go color in my triangle. Side AB. So side AB is the length of that whole big hypotenuse. Side DE. Side DE is right here. And lastly, side BC. BC is that piece. So hopefully from what we've outlined here, it's becoming pretty apparent to you, or pretty clear, that the two triangles that we want to prove similar to each other are the small red guy, so triangle DEA, and that large blue one, triangle BCA. Now already, right from the get-go, we've got that pair of right angles that are going to be congruent. So next thing we need is a second pair of angles. Well, if you look at the red triangle and you look at the blue triangle, they do share an angle. And the angle has to be the same in both triangles. I mean, it can't measure 90 degrees in one of the triangles and 20 in the other. So that angle at A that's shared between the two of them is going to be congruent to itself by the reflexive property. So that gives me two pairs of angles, and that's the gist or the direction that I'm going to take as I go get this proof down on paper. So I'm going to go ahead and start by writing about those two sides being perpendicular to each other. I know that's a true statement because it's given to me to be a true statement. And because those two segments are perpendicular, that tells me that angle DEA is a right angle. Well, how do I know that? Well, anytime I have perpendicular lines, they form right angles. So my reason is because perpendicular lines form right angles. Now, angle DEA isn't the only right angle that I have in the picture. We're given that angle C is a right angle. That too I know is a true statement because it's given to us to be a true statement. So here I've got these two right angles. Anytime I have two right angles, they have to be congruent to each other. I'm going to go ahead and say now that angle C is congruent to angle DEA. And I know this because all right angles are congruent. Now this proof is shaping up nicely because my objective was to write about two of those angles being congruent. I've already got one pair congruent. From the picture I can see that my other pair of angles is here at point A, and I'm all set to go ahead and say that angle A is congruent to itself by the reflexive property. So I was aiming to get two pairs of congruent angles into my proof. I've got it. Once I pull those two statements together, I'm all set to go ahead and say my triangles are similar. So I've got triangle DEA, similar to triangle. And when I name the second triangle, I have to be very careful to match up the corresponding vertices. So in the blue triangle, the vertex that corresponds to or matches up to angle D is angle B. The vertex that corresponds to or matches up to vertex E is vertex C. And lastly, A corresponds to and matches up to itself. And the reason that those two are congruent is because of angle-angle similarity. All right, so now I've got those two triangles similar to each other. I'm going to backtrack a little bit and ask you to remember that when two triangles are similar to each other, their corresponding sides are in proportion. So once I have these two triangles similar, I know that all their corresponding sides are in proportion. And it just so happens that AD and AB are corresponding sides. There's AD in the small triangle. There's AB in the large triangle. And likewise, DE in the small triangle corresponds to BC in the large triangle. So now that I know those two triangles are similar, I can go ahead and talk in my proof about their corresponding sides being in proportion. So let's see, I know that the ratio between AD and AB is the same as what I get when I compare the lengths of DE and BC. And as for a reason, well, I knew that that was a true statement because I had these similar triangles. So I'm going to write about these triangles being similar. So when two triangles are similar, the lengths of their corresponding sides are in proportion. The other fact I know about similar triangles is that their corresponding angles have to be congruent. Well, if I look up here at the second part of what it is I'm being asked to prove, I'm being asked to prove that angle CBA, and angle CBA is this guy right in here, is congruent to angle EDA. And it just so happens that that pair of angles is a pair of corresponding angles for the triangles that I proved similar. So I'm all set to go ahead and say that angle CBA is congruent to angle EDA. And I knew that because I had these pair of similar triangles, so I'm going to go ahead now and write about these similar triangles. So when I have these triangles that are similar, I get pairs of corresponding angles that are congruent. So I think this is a little bit easier than proving triangles congruent because there's a little bit less that I have to do. Two congruent angles gives me a pair of similar triangles. And again, once those triangles are similar, you know those properties about them. You take it from there to finish up the proof. Great, I'm going to go ahead and flip the paper up to the top of the next side. We're given this little reminder here at the top that the product of the means is equal to the product of the extremes. And we'll talk more about what that means here in a few minutes. I'm going to go ahead then and give you a minute to go ahead and mark the givens in your picture. While you're doing that, I'm going to mark the givens in my picture. So hopefully you marked angle ACB as a right angle. And since segment CD was perpendicular to AB, hopefully you put a couple right angles there at point D. Let's take a look at what we're being asked to prove here. We're being asked to prove that a couple of products are equal to each other. Like the proportions, when you see equal products, I want you to think to yourself, similar triangles. So our mission here in this problem is to get two triangles similar to each other. The triangles that I'm going to use have to have sides that are used there in those products. So AD is going to be one of the sides in one of my triangles. CB is going to be a side in one of my triangles. DC is going to be a side in one of my triangles. And then lastly, AC is going to have to be a side in one of my triangles. So looking at my picture, I've now got this red triangle here. And if you've got highlighters, you could probably tell already that highlighters are going to be super helpful when you're proving that triangles are similar. I want to get the purple triangle similar to the red triangle. Well, I've got a right angle in the purple triangle, a right angle in the red triangle. There's one pair of angles. I've also got a pair of angles that's shared between the two triangles. There's a second pair of angles, and that'll give me everything I need to make these guys similar to each other. So let's go ahead and do it. For all you two-column proof lovers out there, this one is for you. I'm going to write some statements and reasons this time around. If you'd prefer to write a flow proof on your paper, of course that's acceptable as well. All right, I'm going to start out by talking about those perpendicular lines. And those perpendicular lines is what gave me the right angles at point D. So I'm going to go ahead and say that angle ADC is a right angle. I know that because perpendicular lines make right angles. I'm going to cite statement 1 because statement 1 is where I had the fact that those two lines were perpendicular. They tell me in the problem that angle ACB is a right angle. So now I've got these two angles that are right angles. Because they're both right angles, it must follow that they're congruent to each other. So that's going to make angle ADC congruent to angle ABC. And that's because all right angles are congruent. And I'm going to cite statements 2 and 3 because that's where I had my right angles. So there's one pair of congruent angles. Our second pair of congruent angles we said we were going to get by using the reflexive property. So if I flip back up for a minute and look at the picture, angle A in the purple triangle is congruent to angle A in the red triangle. So that's going to be my next statement. Now I've got my two pairs of congruent angles. I'm all set. I've set myself up very nicely to go ahead and to say that these two triangles are congruent. So I've got triangle ADC, that's the little red guy. And when I name the second triangle, I need to be very careful to match up those vertices. So A in the red triangle corresponds to A in the purple triangle. Angle D in the red triangle, if I flip back up here and look at the picture, angle D was the right angle. So the right angle that's going to correspond to that in the purple triangle is angle C, which is going to leave angle B for the last vertex. I'm going to cite statements 4 and 5 because that's where I had my pairs of congruent angles. Now once I have those two triangles similar to each other, I know that the lengths of their corresponding sides must be proportional. So I'm going to go ahead and use that similarity to write a proportion. As I do that, I'm going to keep in mind exactly what it is that I'm trying to prove. So I'm going to start out with my first side, AD in the first triangle. AD in the first triangle will correspond to AC in the second triangle. And the other pair of sides I've got to get in there is CB and DC. So I'm going to go ahead and say DC in the first triangle will correspond to CB in the second triangle. And the reason for that, when two triangles are similar, boy, we're getting good at this, corresponding sides are in proportion. I'm going to cite statement 6 because that's where I had the similar triangles. And then the last thing I need to do is remember that the product of the means is equal to the product of the extremes. And what they're really saying with that statement is that we can go ahead now and we can cross multiply. We know that if we cross multiply, the product going in one direction is the same as the product going in the other. So I know that AD times CB going this way in the yellow is exactly equal to what I get going the opposite direction in the green, DC times AC. And if you want to be fancy, you can be fancy and say that the product of the means is equal to the product of the extremes. I'm going to keep it simple and just say cross multiplication. I am going to cite statement 7 because statement 7 is the proportion that I cross multiplied. All right, so if you have questions after watching this video, now would be a good time to do one of two things. Either jot them down at the bottom of this page so that when you come back to class you can remember to ask your questions, or even better still, you could shoot me an email so that when you come back to class I'm already prepared to answer your questions. Regardless, when you come back to class we'll be practicing writing some proofs that involve corresponding parts of similar triangles.